Hey everybody, welcome to our video on Pythagorean Theorem. This concept I'm adding into our unit because we're talking about geometry right now, and you will see some of these skills for Pythagorean Theorem on your state testing. So I wanted to make sure that we are hitting it in our geometry unit before we move into our other algebra unit. So today we are going to talk about the essential question, how can algebraic concepts be applied to geometry? All right, so let's talk about our vocabulary for this lesson. So we're going to be using exclusively right triangles when we're talking about the Pythagorean theorem. So a right triangle is a triangle with one right angle, like this picture over here to my left. The legs of the triangle then are the sides of the triangle that form the right angle. So again, those are labeled in my picture over here. And last but not least, we're talking about the hypotenuse of a triangle, the side that's opposite the right angle. It is also the longest side of the triangle. Again, it's labeled up here in my picture. So we're going to be using a right triangle, the legs of the triangle, and the hypotenuse of the triangle. And we're going to talk about how those are very special when we're talking right triangles. They fall into a formula that when used, we can determine any side length or the hypotenuse length. And that is what we're talking about today, the Pythagorean theorem. So again, the Pythagorean theorem in a right triangle is the square of the lengths of the hypotenuse C is equal to the squares of the lengths of the legs A and B. This formula right here. Again, I have my leg A is squared plus my leg B squared equals my hypotenuse squared, or C squared. We're also going to be talking about the converse of the Pythagorean theorem. And what the converse is if I would take the Pythagorean theorem and reverse it, and a triangle's sides fit this formula, C squared equals A squared plus B squared, then I know that for sure that triangle is a right triangle because it works with the reverse of the Pythagorean theorem. So let's put some of these vocabulary terms into practice. All right, go ahead and jot down this example. Write an equation you could use to find the length of the missing sides of each right triangle. Then find the missing lengths. Round to the nearest tenth. All right, this formula or equation that they're talking about is just our Pythagorean theorem. Our formula, A squared plus B squared equals C squared. So again, my A and B are the legs of my triangle, those sides that form the right angle. So I can go ahead and plug those right into my formula itself. So I'm going to get 9 squared plus 12 squared equals C squared. So this right here is now my equation. And now I can solve for C. So 9 squared is 81. 12 squared is 144. And it's all going to equal C squared. So these two things added together is 225 equals C squared. Now I'm not sure that we've worked with this in the past, but if I have my variable and it is currently being raised to a power or being squared, in order to find out what just one C is, I need to take the square root of both sides of my equation here. So I'm going to take the square root of C squared and the square root of 225. If I take the square root of C squared, it's going to give me just C. And the square root of 225 is actually going to come out to be 15 because my length has to be a positive number. So 15 is my answer. So here's an opportunity to check your understanding. Pause the video right now and try this triangle using our formula for Pythagorean theorem. All right, so in this case, they're not giving you both legs. They're giving you a leg and the hypotenuse, but the formula is still the same. We're still working with our Pythagorean theorem, which is a squared plus b squared equals c squared. And so now I can plug in the parts that I know. So this is one of my legs, so I'm going to say that this is a. 8 squared plus b squared, because b is up here, I don't know what b is, equals 24 squared. Now I'm going to simplify here. I'm going to deal with my exponents first. 64 plus b squared equals 24 squared, which is 576. All right. Now, like my two-step equation solving, I've got to get b by itself. So I'm going to subtract 64 from this side and 64 from this side, and I'm left with b squared equals 512. Now again, I'm down to that last step. When I'm squaring a variable to find what the variable is by itself, or just one of them, I need to do the opposite or find the square root. So again, I'm going to find the square root of b squared and the square root of 512. B ends up being 22.6. Now I'm rounding to my nearest tenth. So it's going to be 22.6 meters, because that's my unit here. So if this made sense to you, you were able to do this on your own, fantastic. If not, make sure you're asking some questions in class tomorrow. All right, last but not least, we're going to just be talking about the idea of the converse. If I flip or reverse the Pythagorean theorem, I can prove that a triangle is a right triangle if it fits my formula. So again, the converse is c squared equals a squared plus b squared. So now in my problem here, it gives me three sides of my triangle. I have a triangle that has sides that are 5 inches, 12 inches, and 13 inches. So I'm going to determine whether that's a right triangle or not. Well, if I needed to draw a right triangle here, I know that my longest side is going to be my hypotenuse, and my other legs are 5 and 12. So I just need to draw it out sometimes so I can visualize it. Now I can plug it into my equation. All right, C is always my hypotenuse, so I know I've got to have 13 squared. And then I can choose which one's A and which one's B. So I'm going to choose 5 for my A and 12 for my B. All right, so now I've got to see if this is going to work out. So 13 squared is 169. 5 squared is 25. And 12 squared is 144. So I have 169 equals 169. Since both my sides equal each other, That means that this triangle described in my problem is a right triangle because I can prove it by plugging it into this converse form or the reverse of the Pythagorean theorem and get it to equal out. All right, so pause here and try this on your own. Try that converse out and see which ones of these triangles that are given below are right triangles. So again, I am looking at c squared equals a squared plus b squared for both of these. C is my longest part of my triangle, my hypotenuse, and then my other two legs, I can enter, oops, not B, I need 48 squared. I can enter in as either A or B. So now let's get our math done here. All right, 60 times 60 is 3,600. 36 times 36 is 1,296. And 48 times 48 is 2,304. So now I'm going to add these together. 1,296 plus 2,304 gives me 3,600. Since these do equal each other, this is a right triangle. If you tried this other one, we can do that one really quickly too. C squared equals A squared plus B squared. 7 is my longest, or my hypotenuse. 4 squared plus 5 squared. 16 plus 25 equals 49. And as you can see, this is not a right triangle because my sides of my equation do not equal out. 49 does not equal 41. So this is not a right triangle because I cannot use the Pythagorean theorem to accurately solve for any of the sides. So, if you have any questions more on Pythagorean theorem, please bring them to class. I will happily answer anything that you have and give the homework a shot. As always, we end with our joke. What do baby kangaroos wear when it's cold outside? Bring your answer and make sure that you're writing down the back of your green sheet for a chance at that Laffy Taffy. Have a great day, everybody.